Hello students, myself Monil Pavagati from Greenwood International School. Today we are going to learn chapter 11, that is mensuration. Mensuration is branch of geometry which includes measurements of length, area and volume. Let us understand some basic formula which we have already studied. First is perimeter of rectangle is equal to 2 into L plus B, where L and B are length and breadth of rectangle respectively. Second, area of rectangle is equals to L into B, that is length into breadth. Third would be perimeter of square, that is 4L, 4 into length. Then area of square, that is L square, which means L into L. Area of triangle, half into B into H, where B is base of a triangle and H is perpendicular height with the base. Then comes circumference of circle, that is 2 pi r, where r is a radius of circle. Area of circle equals to pi r square. Area of parallelogram equals to L into H, length into perpendicular height. Now let us learn about area of trapezium. Area of trapezium is equals to half into A plus B into H, where A and B are the parallel sides and H is the perpendicular distance between two opposite sides. Now, let us learn about area of general quadrilateral. As you can see in the figure, ABCD is general quadrilateral. Now, let us divide quadrilateral ABCD in two triangles, that is triangle ABC and triangle ACD. Here AC is a diagonal. Area of quadrilateral ABCD can be obtained by adding area of triangle ABC plus area of triangle ADC according to the formula of area of triangle. Half into base into height. We'll substitute the formulas. Area of triangle ABC would be equal to half into AC plus H1, where H1 is height of triangle ABC plus area of triangle ADC, which is equals to half into AC into H2, where H2 is the height of triangle ADC. Now, as you can see, half and AC can be taken common. So we get half into AC into H1 plus H2. Now we know AC is a diagonal, so we can replace AC by D. So we get the formula half into the length of diagonal into H1 plus H2. So we can say that the area of general quadrilateral is equal to half into the length of diagonal into H1 plus H2. Here, find the area of quadrilateral PQRS shown in the figure. As you can see in the figure, length of diagonal is 5.5 centimeter, H1 equals to 2.5 centimeter and H2 equals to 1.5 centimeter. As we learned, area of quadrilateral is equals to half into the length of diagonal into H1 plus H2. Substitute the value of D, H1 and H2. That will give half into 5.5 into 2.5 plus 1.5. On adding 2.5 plus 1.5, we get 4. On solving this, we get the area of quadrilateral is equal to 11 centimeter square. Thus, the required area of a given quadrilateral is 11 centimeter square. Now, let us learn about area of special quadrilaterals. First, we'll learn about area of rhombus. Area of rhombus is equals to half into d1 into d2, where d1 and d2 are the lengths of diagonals of rhombus. Let us understand that by an example. Find the area of a rhombus whose diagonals are of lengths 10 centimeter and 8.2 centimeter. Here, the length of d1 is equals to 10 centimeter and length of d2 is equals to 8.2 centimeter. According to the formula of area of rhombus is equals to half into d1 into d2. We have D1 as 10 centimeter and D2 equals to 8.2 centimeter. Just substitute the value of D1 and D2 in the formula. We get the area of rhombus equals to 41 centimeter square. Therefore, the required area of a rhombus would be equal to 41 centimeter square. In the next question, the area of trapezium shaped field is 480 meters square. The distance between two parallel sides is 15 meter and one of the parallel side is 20 meter. Find the other parallel side. Here, length of one of the parallel side is 20 meter. Let the length of that side be A and let the other parallel side be B, and perpendicular distance between them both is 15 meter. Now, according to the formula, area of trapezium is equals to half into A plus B into H, where area of trapezium is given as 480 meters square. Substitute the values. 480 equals to half into 20 plus B into 15. On solving this, we get the value of B equals to 44 meter. Thus, the other parallel side of trapezium is 44 meter. In this question, the area of rhombus is 240 centimeters square and one of the diagonals is 16 centimeter. Find the other diagonal. Area of rhombus is given as 240 centimeters square. Length of one diagonal, that is D1, is equals to 16 centimeter, and let the length of other diagonal be D2. Now, according to the formula, area of rhombus equals to half into D1 into D2. Substitute the values of area of rhombus as well as D1. We get half into D1 into D2 equals to 240, where D1 is 16 centimeter. Therefore, we get half into 16 into D2 equals to 240. On solving this, we get D2 equals to 30 centimeter. Thus, the length of the second diagonal is 30 centimeter. Now, let us learn about surface area of cube, cuboid and cylinder. Total surface area of cuboid is equals to 2 into LB plus BH plus LH, where L is length, B is breadth and H is height. Lateral surface area of cuboid is equals to 2 into LH plus BH. Total surface area of cube is equals to 6L square. Lateral surface area of cube is equals to 4L square. Lateral surface area of cylinder is equals to 2 pi RH, and total surface area of cylinder is equals to 2 pi R into H plus R. Let us try to understand the example. The aquarium is in the form of a cuboid whose external measures are 80 by 30 by 40 centimeter. The base, side, faces and back face are to be covered with a colored paper. Find the area of paper needed. Here you can see the length of aquarium is given as 80 centimeter, width of aquarium, that is breadth of aquarium, is given as 30 centimeter, and height of aquarium is given as 40 centimeter. Now we'll find out the area of base, that is L into B. On substituting the value of L and B, we get the area of base equals to 2400 centimeter square. Now if we check the area of side face, that is base into height, we get the area of side face as 1200 centimeter square. Now area of the back face is equals to L into H, that gives the area of back face as 3200 centimeter square. Now the area of paper needed would be equal to the area of base plus area of back face plus 2 into area of side face, because aquarium would be having two side faces. So the total area would be 2400 plus 3200 plus 2 into 1200, that is 2400. On adding all the three areas, we get the area of paper needed would be 8000 centimeters square. Here in this question, the internal measures of a cuboidal room are 12 meter by 8 meter by 4 meter. Find the total cost of whitewashing all four walls of a room. If the cost of whitewashing is 5 rupees per meter square, what will be the cost of whitewashing if the ceiling of the room is also whitewashed? Let the length of the room be 12 meter, width that would be the breadth, that is 8 meter, height equals to 4 meter. Now the area of four walls would be equal to 2 into LH plus BH, that is lateral surface area of a cuboid. On substituting the value of L, B and H, we get the area of four walls equals to 160 meter square. Now cost of whitewashing per meter square is 5 rupees. Hence the total cost of whitewashing four walls equals to 160 into 5, that is 800 rupees. Now area of ceiling would be equal to L into B, that is 12 into 8, that is 96 meter square. Now cost of whitewashing the ceiling is 96 into 5, that is 480 rupees. Now if we calculate the cost of whitewashing, if the ceiling of the room is also whitewashed, then that would be 800 plus 480, that is 1280 rupees. In this question, in a building there are 24 cylindrical pillars. The radius of each pillar is 28 centimeter and height is 4 meter. Find the total cost of painting the curved surface area of all pillars at the rate of 8 rupees per meter square. Here, the radius of cylindrical pillar, that is R equals to 28 centimeter. First of all, we'll convert centimeter to meter. So we get R equals to 0.28 meter and height is given as 4 meter. Now we know the formula of a curved surface area of cylinder, that is 2 pi RH. So on solving this, we get the value of curved surface area of pillar as 7.04 meter square. Now we know there are such 24 pillars. So total area would be 7.04 into 24. That is 168.96 meter square. Now in the question it is given that the cost of painting is 8 rupees per meter square. And here we have area of 168.96 meter square to be painted. So total cost of painting would be 168.96 into 8, that is 1351.68 rupees, 1351.68 rupees. Now let us learn about volume of cube, cuboid and cylinder. Volume of cube is equals to L cube, that is L into L into L. Volume of cuboid is equals to L into B into H, where L is length, B is breadth, and H is height. And volume of cylinder is equals to pi r square H, where r is the radius of cylinder and H is height of cylinder. Let us take an example. Find the height of a cuboid whose volume is 275 centimeter cube and base area is 25 centimeter square. Volume of cuboid can be found by multiplying base area and height. So we can say that height of a cuboid can be obtained by volume of cuboid upon base area. We have volume of cuboid as 275 and base area as 25. On solving this, we get the height of cuboid as 11 centimeter. Thus, the height of cuboid is 11 centimeter. In this question, a rectangular piece of paper 11 centimeter by 4 centimeter is folded without overlapping to make a cylinder of height 4 centimeter. Find the volume of the cylinder. Here, length of paper becomes the perimeter of the base of the cylinder and width becomes height. Let the radius of cylinder be r and height be h. Now we know that perimeter of base of the cylinder is 2 pi r, that is 11. On solving this, substituting the value of pi as 22 by 7, we get the value of r as 7 by 4 centimeter. Now we know the volume of cylinder is pi r square h. Now we have the value of pi as 22 by 7, r as 7 by 4 and h as 4. On substituting all the three values, we get the volume of cylinder as 38.5 centimeter cube. Thus the volume of cylinder is 38.5 centimeter cube.